Hello class, a very warm welcome in today's session. In today's session, we are going to continue our chapter that was sound. In the previous session, we were discussing about the characteristics of a sound wave. The characteristics of a sound wave is determined by the three terms. What were those three terms? We were discussing about that. As you can see on your screen, that a wave produced by a continuous disturbance in a medium. The wave is produced by a continuous disturbance in a medium. We know that very well, right? So in order to describe a wave, we generally use the terms frequency, time period and amplitude. So generally, whenever we want to describe the characteristics of a wave, we always use three terms, that is frequency, time period and amplitude. Now you will be confused that what is frequency, what is time period and amplitude. Even we have studied this in previous session. I am going to do a quick recap about these terms. You can see the very first term is frequency. So frequency of a wave is the number of vibrations or cycles completed by it in 1 second. Like you can see here, this is a wave produced, something like this. So the number of vibrations, like this will be one cycle, this will be one cycle completed here, this will be second cycle, then this will be third, this will be fourth. Okay, so what is happening, that this whole portion is known as one cycle. This will be second, this will be third and this will be fourth. So number of cycles and number of vibrations completed by a sound wave in a second, that is known as the frequency of that particular sound wave, right? It is denoted by small f and its SI unit is hertz. Okay, we denote it as capital H small z. This is pronounced as hertz. Okay, for example, if a source produces 10 vibrations in 1 second, so it is said that it has a frequency of 10 hertz. Okay, this is what is all about frequency. Now moving ahead, we have the next topic, that is time period, the next term that is related to the sound wave. Okay, so what is time period? Time period of a wave is the time taken to complete only one vibration or a cycle in particular unit of time, like in whatever time it is taking to complete one vibration or one cycle, that will be the time period of that particular sound wave. Okay, so that is what is written here. Time period of a wave is the time taken by it to complete one vibration. It is denoted by capital T and is measured in seconds. Okay, so we are going to measure it in seconds. Obviously, we are going to measure time in seconds. We know that very well. For example, if a source produces 10 vibrations in 1 second, its time period will be 1 upon 10 or 0.1 second. Okay, I hope you understood the point, that what is frequency and what is time period. Now moving ahead, we have the third term that is related to the sound wave, that is the amplitude. This is a very confusing topic, as I have already elaborated in the previous session, right? So what is amplitude? The maximum displacement of a wave on either side of its mean position. Okay, now what is the mean position? Firstly, you have to understand that. Okay, this is a wave starting from this point, okay, like this, something like this. Okay, and if the wave is starting like this, so what is happening, this will be the mean position of the wave. So you understood that what is the mean position? Mean position is that position from which the wave is initially starting, right? So from this mean position, the maximum distance that a wave is covering either side of the mean position, like this will be the one side and this will be the other side. So it is covering this distance and then again this distance, this distance, this and this. So these all will be the amplitude of this particular wave. Okay, so the distance that is covered by the wave on either side of its mean position will be the amplitude of that sound wave. Okay, its SI unit is meter. Obviously, we are saying that the distance covered, so SI unit of distance is meter. Okay, the amplitude of a wave is the measure of its energy. Two waves with the same frequency can have different amplitudes. I have told you in the previous session that whenever we have two waves and if they have the same frequency, they can have different amplitudes. Okay, I hope this is clear. You can take the screenshot. Now moving ahead, the new topic, the very new topic of this session is the example. Obviously, we are going to start with the example because we have studied the three terms. Okay, the very first example says the frequency of a sound wave is 200 hertz. Okay, what is its time period? Now, if you remember, I have told you that what is frequency and what is time period. Okay, so the relation between, I am going to tell you that what is the relation between frequency and time period. Frequency is equals to 1 upon time period. Obviously, you know that frequency is what? The time taken, like if an object, like if a sound wave is producing different vibrations in per unit time, so that will be the frequency. So frequency is equals to 1 upon time period, and here the frequency is given like this, 200 hertz. So 200 hertz is equals to 1 upon t, and if you want to find out the value of t, you have to transfer it here, and then 200 will be transferred here. So it becomes t is equals to 1 upon 200, so which will be 0.5 into 10 to the power minus 2, which is 0.05 seconds. Okay, because we are denoting the time period, so time period will be denoted in seconds. You can see here, this is completely written here. Okay, I hope this is clear to you. You can take the screenshot of this example. Now moving ahead, we have loudness or intensity of sound as the other topic. See, we have understood the main topic, that is amplitude. Okay, now we are going to study that what is loudness or intensity of sound. Okay, loudness always depends upon the intensity. When we are talking about the intensity of sound, we are talking about the loudness, obviously. Okay, so loudness is the characteristics of sound which distinguishes a feeble sound from a loud one of the same frequency. So loudness means that we are basically distinguishing between a loud and a soft sound, right, on the basis of the frequency generated. Factors affecting loudness. Now what are the factors that affects the loudness? Firstly, you have to see here that we have two graphs. Okay, this will be the graph of higher amplitude, that is the loud sound. Okay, whenever any wave has higher amplitude, this will be the higher amplitude, right? This will be the amplitude. So you can see that this wave is creating higher amplitude, but in this case their amplitude is minimum or smaller, so that's why this sound is small and this sound is greater, like we can say loud sound. Okay, so what is the point that you understood from this graph? That higher the amplitude, louder the sound, and lower the amplitude, softer the sound. So this is what is the crux point of this graph. You can see the very first factor that affects the loudness is what? It is the amount of sound energy received by a unit area per second. It is the amount of sound energy which is received by per unit area. Okay, loudness of a sound depends on its amplitude. I have told you, higher the amplitude, louder is the sound. As the amplitude of a wave is directly related to the energy it carries, we can say that greater is the energy carried by a wave, louder is the sound produced. We know very well that amplitude is directly related to energy. So obviously if the altitude is higher, louder will be the sound, and we know that amplitude is related to energy, so higher the energy, louder the sound. Okay, I hope this is clear to you. You can take the screenshot of the very first factor. The second factor that affects the loudness is loudness increases with an increase in the area of the vibrating body. Like if I am saying I have a dholak and the membrane is like this, okay, and I have a bigger dholak and the membrane is like this, so you will practically determine that when I am beating this, this is producing loud sound, and when I am beating this, this is producing slow sound, like if I can say that is soft sound. Okay, so that's the relation between the area and loudness. Okay, loudness increases with an increase in the area. If I am increasing the area of the vibrating body, then the loudness is going to be increased. Thus a large drum will produce a louder sound than a small drum. Okay, this is the second factor which affects the loudness. The second factor is what? Area of the object, area of the sound producing object. Then the third factor is what? Loudness also increases with a decrease in the distance between the listener and the source. Like if I'm standing here and if you are standing there, okay, if you are standing in front of me and if I'm talking to you, the distance is very less, okay, you will hear clearly my voice. But if you are at a greater distance, you will hear my voice in a very slower manner, right? So that is what is here, the third factor, which is the distance. So larger the distance, softer the sound, okay, and smaller the distance, louder the sound. Okay, loudness also increases with a decrease in the distance between the listener and the source. So a sound of the same frequency heard at a small distance will be louder than when it is heard at a greater distance. Obviously I have told you that what is the relation between the distance and loudness. Basically loudness is inversely proportional to distance, and distance is in between the source of sound and the listener. Okay, you can take the screenshot of these both factors. Now moving ahead, we have the last factor that affects the loudness. What's that? Some other factors on which the loudness of a sound depends are the atmospheric temperature, pressure, velocity of the wind, and the amount of moisture present in the air. So these are the other factors which affects the loudness. You can take the screenshot of this fourth factor. Now moving ahead, you can see that the next topic is reflection of sound. Now you will be confused that sound reflects as well. Yeah, sound reflects. As in the case of light is also reflecting itself, so sound is also reflecting itself. Why I am saying that sound is reflecting? Why my voice is clear to you? Because my voice is bouncing in the walls around me, in the ceiling around me. So that's why I say that sound also reflects. Okay, like light, sound also gets reflected. Now the second topic is good and bad reflectors of sound. Okay, what are good reflectors and what are bad reflectors in sense? Hard materials with smooth surfaces such as metals, metal alloys and cemented walls are good reflectors. Basically, like the hard materials which are smooth, which have smooth surfaces, so they will reflect the voice very clearly. Okay, they are going to reflect the voice very clearly. So the walls are good reflectors of sound. Soft and porous materials. Now if I am talking about the soft and porous materials such as clothes, carpets, paper, thermocol and asbestos are bad reflectors of sound. So these are the bad reflectors. Okay, they are actually good absorbers of sound. They are bad reflectors, so that's why we can say they are actually the good absorbers of sound. Okay, I hope this is clear to you that what is the reflection of sound and what are good and bad reflectors of sound. You can take the screenshot. Now moving ahead, you can see here that we have the next topic, that is echo. So you will be confused that what is echo. Let me just tell you. Echo is something that an echo is a repetition of sound produced by the reflection of sound waves from a reflecting surface. Like in a very big hall, if I shout, so what will happen? My voice will reflect back and I will hear my voice after some time. Right, after a, like we can say 0.1 second, 0.2 second, nanosecond. In nanoseconds we are going to hear my voice. Okay, so that is what is an echo. If you stand in a big empty hall and shout loudly, you will first hear your own voice and a little later you will hear the repetition of the same sound. Okay, so that is what is an echo. The second sound is the reflection of your original sound reflected by the walls of the hall. The second reflected sound is called an echo. So the second reflected sound that is coming back to you, that will be the echo of yours. Okay, so this is what is echo. Now moving ahead, you can see why do we not hear an echo in a small room, like in this small room in which I am going to record the lecture. So what is happening in this small room? My voice is not reflecting. Why? Because in the small room there is not much distance in between the walls, in between the ceilings, but in an auditorium, in a hall, there is a much difference between the walls and like ceiling. So that is why there is a time, there is a bigger time, we can say there is a maximum time of my voice that can travel and bounce back, and that's why I can hear my sound. Okay, our brain retains the effect of every sound for 1/10 of a second, 0.1 second, and so cannot distinguish between two different sounds if they reach the brain within a duration of 1/10 of a second. In order to be heard as two distinct sounds, the two sound signals must reach the brain at a time interval of more than 1/10 of a second. This is why in a small room we hear the original sound and the reflected sound at the same time. Okay, I hope this is clear. You can take the screenshot. Now moving ahead, we have, this is the reason why the walls, ceilings and floors of auditoriums and cinema halls are covered with sound absorbing materials, and that's why we use sound absorbing materials in bigger halls, in auditoriums and cinema halls, so that the sound cannot reflect itself and the echo is not created. Okay, such as thick soundproof tiles, curtains and carpets. These are the good absorbers of sound. Now moving ahead, you can see that minimum distance. What is the minimum distance that is required for occurrence of an echo? So we know that the speed of sound in air is 344 meter per second and the minimum time required to hear an echo is 0.1 second. I have discussed before that it is 1/10, which is 0.1 second. Okay, so in 0.1 second I am going to hear the echo, but if the distance becomes lesser, so what will happen? It will happen that I can't hear the echo. So what is the minimum distance I can hear the echo? See, so the distance traveled by the sound in 0.1 second is what? We know that speed is equals to distance upon time. We know that very well, right? So if I am going to find out the distance, so distance becomes speed into time. So speed is 344 meter per second and time is 0.1 second. So I am getting the distance as 34.4 meter. Now there is a thing. What's that? That my sound is going to cover the distance twice, right? The sound is going to the wall and then it is coming back. So it is covering twice the distance between me and wall. So that's why I'm going to divide 34.4 by 2, which in return gives me 17.2 meter. It is written here as well, as the sound travels twice between the source and the reflecting surface before an echo is heard. The minimum distance required between the source and the reflecting surface to hear an echo is 34.4 upon 2 meter, which is 17.2 meter. Okay, so you can take the screenshot of this. Now moving ahead, you can see conditions required for the occurrence of an echo. What are the conditions that are required for the conditions like the occurrence of the echo? Okay, so you can see the very first condition is the minimum distance between the source of sound and the reflecting surface is around 17 meter. Approximate value is 17 meter, but the exact value is 17.2 meter. We have found it in the previous slide. Okay, there is a high wall or a hill. Now the second condition is what? There must be a high wall or a hill or a high rise building which can act as a reflecting surface. Okay, so there must be a high wall, hill, or whatever. There will be there will be an object which can echo your sound, which can produce the reflection of your sound. Okay, then the next one is the sound is loud enough so that it reaches the receiver after reflection. The sound should be louder enough so it can be received through the receiver and get back to you to produce an echo. So these are the basic we can say conditions for the production of an echo, right? So this is what we have studied in this lecture. In the next lecture, what we are going to do, we are going to do some more interesting topics as well as some more important concepts. Till then, what you have to do, you have to revise the whole lecture. Take care of yourself, keep learning and keep exploring. Thank you so much. Bye bye.